Hello, everybody. Good morning. Nice to see you. Hello, Bo. Hello, Ali.
Good morning.
Morning. Oh, hello, Patricia. Gosh, you are early this morning.
Well, the trick to this is just not go to bed.
Well, so there is that.
There's
Yes.
that. Yeah.
Well, hopefully I won't give you nightmares.
Nice to see you again. Hello, Greg. Hi, Hannah. Hello, Mr. Harper. Hello, Magnus. Nice to see you. Hello, Mr. Butlin. Nice to see you again. Hi, Malcolm. Right, let's get started. So welcome to day 3 of the security stream for the GSE Virtual Conference 2023. So yeah, this is our last day. We've got a few sessions today here on the security stream. So after Christian has finished, we'll just remind you about those. If you've been collecting or storing up your feedback to complete, do get that completed as soon as possible. Just a quick reminder that you know, it not only contributes to your CPE points if you want a CPE certificate, but also it's good for the presenter and also good for us at GSE, so we can give you a bigger and better conference. So without further ado, I'm going to hand over to Christian, and I always get his name wrong. Karachi, did I get it right?
Yes, you get
Oh,
it.
that's good. I see I'm improving.
Yes, there have been so many years since you introduced me.
I've had plenty of practice, haven't I?
Yeah, exactly.
So Christian is going to come and talk to us about digital forensics and how it applies to mainframe. As an FYI, Christian, and no pressure on him, he's up next at 10:30. If you're interested in forensics in the 101 stream, so hopefully you'll be able to join him for that as well. But anyway, Christian, the stage is yours, sir. Thank you.
Thank you very much. Hello, everybody. Good morning, good evening, good afternoon, wherever you are in the world. It's a pleasure to present to you again. This time, the D4 and the big iron. As you have probably already guessed, D4 stands for digital forensics. And I have to admit I'm a bit nervous because this presentation of mine is out of the ordinary. In fact, I don't have any demos to share with you, which means you are stuck with me for the next hour or so. So let's get started. Okay, not working. Hang on a second. Oh, yes. Okay, what is digital forensics? It's the gathering and analysis of digital information in authentic, accurate, and complete form for presentation and as evidence in a civil proceeding or a court of law. The digital forensic process involves gathering information from documents, communications like instant messages, emails, text messages, databases, and for proprietary data for application. There are the laws related to cyber forensics are heterogeneous across the world and are still in the evolving stage. Maybe you're asking yourself why this guy keeps beating the bush around digital forensics for the past several years now. Well, there are a few reasons. One of them is I was and I still am part of several computer incident response teams, and what I noticed, whether it was a real world incident or a tabletop exercise, 9 cases out of 10, the teams were concerned with contain and eradicate the incident as soon as possible. Nothing wrong with this, but in this case, they disregarded the advice of the digital forensic member of that team. In some teams, they don't even have a digital forensic examiner. And then they find themselves sucking their thumb, pardon the expression, and trying to find evidence to present it to the police or the judge. They're trying to drag the responsible people in front of a judge, but it's impossible because they have no evidence. Real life story. A while back, company had an incident. They were somehow prepared in terms they had a server that was already there to replace their server in case of the incident. But this is bitter funny, if you want. The incident involved an employee, a disgruntled employee that was quite up in the hierarchy of the company. They employed the services of a hacker who created a logical bomb. Probably you know what a logical bomb is. It's a piece of software, a malicious piece of software that activates at a certain point in time. Now, this employee added this logical bomb to their weekly update. So the weekly backup, sorry. The weekly backup happened to a remote site, as it should. So the logical bomb was there. The incident occurred. What they've done, they've unplugged the server from the network and from the power, throw it away, smash it with a sledgehammer, put the new server in, and they pulled the backup from the DRS. Within the hour, they were back to square one because they didn't check the backup. So the logical bomb activated within the hour after they restored everything. So was no time for champagne or canapes or whatever, or celebration, because they were back. Now there is another reason for me to do this, and this is funny indeed. Every now and again I receive the odd phone call or message from different forensic labs here in UK or around the world. They try to offer me a job, and we start talking. I did this and that. I did the other. For obviously I'm not naming the companies. And at some point they pop up a question, and the question is, how familiar are you with ISO 17025? I have to tell you, at that point in the conversation, I suddenly remember either that my dinner is burning on the stove, or I have to walk my dog, or I have some sort of other emergency, and I hang up because every single time what pops up into my mind is this thing, which I want to share with you. So this is me.
You, there. What is your profession?
I'm a potter, sir.
And you, Arcadian. What is your profession?
Sculptor, sir.
You?
Blacksmith.
Spartans! What is your profession?
So, okay. Yeah. ISO 17025 is the main international standard for general requirements for the competence of testing and calibration laboratories. It gives a framework for testing and calibration standards, staff competence, equipment standard, and quality management. When we talk about digital forensics, we have ISO 27027 37, guidelines for identification, collection, acquisition, and preservation of digital evidence. 27041, guidance on the assurance aspect of digital forensics, e.g. ensuring that the appropriate methods and tools are used properly. 27042 covers what happens after digital evidence has been collected, i.e. its analysis and interpretation. And we have 27043 that covers the broader incident investigation activities within which digital forensics usually occur. Locally in the UK, we have the Association of Chief Police Officers Good Practice Guide for Digital Evidence. Now, a little bit of background. The digital forensic and electronic discovery process has the following 5 stages. First stage is identification, where potential sources of relevant evidence and or information, namely devices, are identified and nominated, as well as key custodians and location of data. We have preservation, is the process of preserving relevant electronically stored information by protecting the crime or incident scene, capturing visual images of the scene, and documenting all relevant information about the evidence and how it was acquired. We have the third stage, and that is collection. In this stage, the digital information that may be relevant to the investigation are collected. This may involve removing the electronic device or devices from the crime or incident scene and then imaging, copying, or printing out it or their content. The fourth stage is analysis, where we take an in-depth systematic search of evidence related to the incident being investigated. The output of this investigation are data objects found in the collected information. This may include system and user-generated files. Analysis aims to draw conclusions based on the evidence found. And we have the final stage, that is reporting. And reports are based on proven techniques and methodology. And secondly, other competent forensic examiners should be able to duplicate or reproduce the same results. That means, for example, if I'm doing a forensic investigation and then I'm presenting my evidence in a court of law, the defendant solicitor can bring their own forensic examiner to examine my evidence and the way I preserved and found it. So I have to do it in such a manner that other competent examiners should reach the same result, whether they're using my tools or different tools. Okay, now the big iron. The first 2 stages are quite okay. We're not very concerned about them because we don't always really have access to the data center. But I will draw your attention on this, because this stage is the collection stage, is where we collect the information. So by removing electronic devices from the crime scene, it means we remove laptops, PCs, cameras, digital cameras, digital recorders, MP3 players, CDs, DVDs, whatever is used to store information in a digital way. Now, good luck with removing either a mainframe or a DASB from the scene, if you have access to the scene. So obviously we don't have to remove that. So let's have a little look at the mainframe, at the CAC itself. We do have up to 85 LPARs for each mainframe. We do use up to 16 terabytes of memory in ZOS 2.5. This is with some restriction. We also have one master catalog per CAC. And regardless of the number of DASDs connected to that mainframe, we have user catalog and volume table of contents for each DASD, which means that if we have, let's say, 10 volts here connected to this mainframe here, we will have 10 user catalogs and 10 volume table of contents. Okay, so how do we perform digital forensics on a mainframe? First, we will capture an image of the logical partition that we are interested in. But whether it is ZOS, whether it's Linux on Z, or whether it is the ZOS inside the ZVM, inside the virtual machine, is irrelevant. The maximum size will still be 16 terabytes, which is achievable. We carve the data from the master catalog. Then we go further down the line and we carve the data from user catalog and the volume table of contents. We capture an image of the data set or set we are interested in. Obviously, we analyze those data. So, I was quite fast. Yeah, I usually have demos. Unfortunately, at this stage in this process, I don't have demos. So let's summarize this a little bit. Digital forensics is an ever-evolving science, which is backed up by ever-evolving laws. Now, collection of forensic artifacts on a mainframe is challenging because it's sophisticated and complex architecture. And our methods can and should evolve to meet the challenges. And if you think I can help you in any way, please reach out to me to find out more. Now, if you have questions, feel free to ask them. We have about half an hour for question Q&A.
You can unmute your lines, folks, if you've got any questions you want to fire at Christian, or you can put them in the chat. So I'm curious to know from anyone out there, like, and you don't have to reveal your company name or anything like that, but around the business of investigations and things. I mean, that's something that have you ever been involved with at all? Like, you know, with a kind of crime, you know, that's potentially being committed.
Yes, I have been involved. It's how I started in digital forensics.
No, sorry, Christian, the question was more general for the audience, just to see if, yeah. Stunned silence. So you were saying, Christian, you've been involved with a few investigations then before with.
Yeah, well, how I started is quite funny. About 3 decades ago, I received a phone call in the middle of the night asking me to attend the site and tell them they've lost a really important partition on their server. They were working for the Italian government, that they had really important data there. So the combination wasn't the best one for Windows 24 as a server, and the workstations were Windows 90, probably most of you remember that dreadful combination. Anyway, I restored the partition, I restored the data, and then I started testing to test the workstations to see if they still connect to the server. And at some point, I noticed that one of the stations had a keylogger that was loaded at the start of Windows. So that keylogger, respective user, they said that their purpose was to find out the password to connect to the internet. Obviously, that guy was promoted immediately from PC operator to job seeker. And this is how I started in digital forensics. Basically, it was like an accident, but I always had a passion for digital forensics. Yeah, so I evolved with the times and the challenges. So now I devised this methodology to perform digital forensics on a mainframe. I'm quite sure I'm the first one to do that because I'm not aware of any company or any other software vendor who did that before.
So can I ask then, how long typically would if you're doing forensics on a computer system, how long it would sort of take? I mean, I guess it's how long is a piece of string depending on what's been done.
Yes, exactly. Now that would depend very much upon the investigation. Let me give you a real example in the mainframe world. Say a user is involved in trafficking in contraband. Usually this is child pornography or selling copyrighted digital content. They store all these pirated or child pornography images on a mainframe. Obviously, that mainframe has thousands, tens of thousands of users, and as you know, the mainframe is performing billions of operations every single day. We cannot, obviously, and it's not practical to image 5.9 petabytes of data. We will need another maker, another DASI to do this. But what we can do, and this is the beauty of it, once that we have the perpetrator, the bad actor credentials, we can locate him in the master catalog and then go further down the line and find out on which DASI and which data set belong to that bad actor. So the only thing that we image is LPAR, the logical partition, where the operating system sits. Like I said, either it's ZOS, Linux, and that is irrelevant. We image the master catalog, and then we go further down. We don't necessarily need to image the user catalogs or the volume table of contents. We are not interested in that, but we are interested in the data sets that belong to that respective user. So we image those data sets and we analyze the data from those data sets. We don't need to image the entire DASI for it. So it's a really granular process. Now, if we deal with PCs or laptops or memory sticks or DVDs or some other electronic devices that store digital information, is relatively quite straightforward. We do have loads of applications to do this. We have NPs, we have Bitigo, we have Telcasoft, FTK Imager, FT Disk Analyzer, and so on and so forth. Some of them are very strong, some of them are not that strong, some of them will find almost everything, some of them will find almost nothing. But this comes down to the competence of the person using it. So as you said, Jamie, how long is a piece of string? Depends.
Well,
a few hours. It might be in the case of a large organization. For example, I've been involved in investigations that took weeks, not 1 day or 2 days, weeks, because it was a large amount of data, and I had to granulate each and every one of them. So,
yeah, I'm just trying to sort of compute, like, for say there was some fraud or something on like one of the, I mean, there's a few people from banks on this call, like some of these huge applications, huge amounts of application, data sets and things and DB2 tables and things kicking around, terabytes and terabytes and terabytes. I'm just trying to, sort of comprehend the scale of it. And particularly if it was suspected that, that as we've had historical cases of fraud involving the mainframe have gone on for like years, and undetected, for years. And I'm just trying to, sort of in my mind, gosh, that would be one huge investigation. Yeah. And
Yeah,
where do you start?
they go undetected mostly because everybody is thinking that because of the sheer amount of data and that the mainframe processes every day or every second, if you have, every minute, it's impossible. No, it is not impossible. You have a starting point, and that is the bad actor. That is the event that triggered the alarm, the event that raised the red flag. Whether it is malware, whether it is data exfiltration or credit card fraud or whatever, these can be tracked back to the user who generated that event. It is, like I said, it is a granular process, involves a lot of work, but it is doable. It is doable.
Okay. Interesting. So any other questions from folks out there? You can unmute your line if you want to ask Christian a question.
Hi, it's Kira.
Hello.
Hello, Kira.
I would say most of the stuff that I have been involved on, if you like, from the fraud side, it's always been people using access that they legitimately had, but for bad reasons. So it has been the application audit trail that has been critical to prove they were the person who did ran a transaction at a certain date and time. But it's tend to be needed in the application space. I don't know whether to say luckily or unluckily, I've never got to play with an actual investigate a real hack on the mainframe. If you know what I mean, penetration from the outside.
Yeah.
It's always been, the disgruntled employee and why you always have to take 2 weeks off together in a financial institution to try and stop fraud.
Yeah. I mean, this is the thing that I thought the cases that I've heard about in mainframe, is and criminal fraudulent activities has always, apart from the one that a lot of people talk about up in the Nordics, putting that one aside, it tends to be the insiders because of the years, the decades of knowledge that some people have about these systems. Yeah.
Yes, probably you noticed that I gave up that insider thing that I'm presenting in the enterprise security, and I moved it to the 101 stream. So it's the insider perspective in the 101 from a digital friend, but I moved it. I feel this is more appropriate for the enterprise security. So obviously I will continue presenting on this topic.
Indeed. Yeah. Interesting. So yeah, any other questions or thoughts from anybody, any of our viewers?
Feel free to ask. There are, like many other presenters said before me, the only stupid questions are the ones that you don't ask. Oh, we still got half an hour, so.
I think you might have scared people, Christian.
Well, this is what I usually do. It is not my purpose to scare you, don't get me wrong, please. My purpose is to educate you and to share with you my experiences. Some of them are not pleasant at all, believe me. They're not pleasant at all. They're very traumatizing.
So I'm curious, so have you actually had to go to court and things and present evidence, or Is that, or is it kind of just sort of you do your investigations and give it to the kind of client you're working for, and then that's it?
Oh, me?
Yes.
Oh, well, yeah, I'm freelance, so obviously I'm a contractor, so I'm doing the
I
job.
work for the client. Yeah.
Organization, the other organization. I give them the evidence, and that's the end of contract. We shake hands, get paid, move on.
Yeah.
I, like I said in my opening remarks, sometimes I do receive the old phone call or text message or email asking me to fill in a position, but after a few minutes, that scene pops into my mind. So I keep doing what I'm doing freelance.
Okay. Very good. Very good. All right. So just final call then. Any questions, comments, thoughts from the audience? Like I say, you can unmute your line. Otherwise, we'll give you half an hour back. Nope. Okay, so thank you very much, Christian, for your session. Yeah, don't forget your feedback, and I'm just going to post this link in the chat. Promise it's not a dodgy link.
Thank you very much. Thank you very much for having me again.
No problem. So, yeah, there you go, folks. The link to Christian's feedback is there session 7M, or you can click on the QR code, and that will also take you to the feedback site. Just a couple of things. So as I mentioned at the beginning, Christian is on the 101 stream at 10:30 with continuing his theme of digital forensics. So it's Gone with the Bytes, a digital forensics saga. So that's, like I said, at 10:30 to 11:30 in the 101 stream. In security, we're actually taking a break now until 12 o'clock UK time, and the session will be with Isha Powers. I know many of you know Isha. She is like Mrs. Crypto. So she's got 2 crypto sessions, one at 12 o'clock UK time, and then one at 2 o'clock, all around crypto. And then the final session in security will be at 3:30 with Mark Nelson, where he'll be talking about a path to an encrypted data set. So hopefully you will be able to join us for that. While we're taking a break at 10:30, if you're not going to Christian's session, there are other sessions running, you know, in the other streams as well. So do have a look at the agenda. I have mentioned this a couple of times now. Also, a date for your diary. We are going to have our security working group meeting on Thursday, the 29th of June. And as I said yesterday, we're trying to just find a venue for that, because we're doing a hybrid. This is our first kind of get together for a working group. We've been doing them virtually, as you know, for the last couple of years. So we're going to get back together again. But like I said, it's going to be a hybrid. So you will be able to join us through Zoom if you prefer. And also we're looking for presenters for that meeting. So hopefully you'll be able to put a paper in and so that you can present for us. So any closing thoughts, Christian, before we go?
Yeah, well, I hope you enjoyed the session. I will try for my next presentation to show you some demos as well, because my presentations without demos are quite dull, as you can see, very short. So it took me 15 minutes to do something without the demos. But I promise you next time we will have some demos.
Very good. Okie dokie. All right then, folks. So we'll give you back. Next session starts at 10:30. Check the agenda, and we'll see you later on the security stream at midday UK time. Take care. Thank you, Christian. Bye bye.